we will get started. Good morning, everyone. Thank you for joining us on the final day of the Cali conference. Saturday mornings are tough, especially on the last day of a conference. So it's great to see everybody here. My name is Jason Tubinis. I am the IT librarian at the University of Georgia Law Library. And this is...
I'm Leslie Grove. I'm the web developer.
And we'll be going over the 6 things every beginner needs to know about coding. So what does a beginner need to know about coding? You need to go and buy this copy of Bloomberg Business Week. This is the June 15th to 28th issue article. This came out last week, and so technically this is this week's issue. We were all really, Leslie and I were really excited to tell people, like, here's everything you need to know, and this is going to be completely novel and new, and then this Paul Ford comes out with this 38,000 word magnum opus. It takes up this much of the magazine. It's the entire article, basically. And it goes over what is code, how does code become software, why do coders like going to conferences so much, why are coders so rabid about their language of choice, why are there so women who take up the profession of coding. How great is GitHub? So great or the greatest? It goes over all these nice things. So why don't we all promise to go pick up, I'm not being a total shill here, go pick up the Bloomberg Business Week, promise to read it, and we can all just end this session at like 90 seconds. No, I'm playing. So, what is everything, what are all the things you need to know as for a beginner about code? Now, we're not going to teach you to code in 45 minutes. If we could do that, Leslie and I would probably quit our jobs, move to the valley somewhere, and be making buckets of cash teaching people to code in a fraction of the time it actually takes. So we'll be going over just the things you need to start on your journey. We're going to teach you what a fishing rod is, how to put the bait on the line, and how to cast properly. After that, we've got some resources that start getting your hands kind of dirty in a very safe environment with code. But as we're talking about code, it's important to know what we're not talking about. If anyone here is worried that we're going to be talking about fancy HTML tags or how to properly style your CSS or get the most out of your database queries, we're not going to be touching any of that in this session. When I first started on my journey to coding many moons ago, if I saw a bunch of numbers and letters and symbols and half words, I'm like, oh, it's code. And for the most, in a very broad sense, yes. But that's not what we'll be talking about in this session. Code and programming language have a very specific definition for this topic. I'd like to use HTML as a good example. It's more of a description. It's a format. A heading tag is just a suggestion. It depends on the browser that it's running through. A heading tag in Firefox can be huge. A heading tag in a proprietary browser of some sort can be just tiny and stupid. All of these CSS queries, spreadsheet formulas, they require another piece of software to kind of work. What we're going to be talking about is the stuff that makes all that stuff work. It's the language that interacts directly with the computer.
So when we talk about code, what we really mean is a computer programming language. And like any language, a programming language has different parts and rules about how these parts can be put together to create something that has meaning. And it's a compromise between how humans speak and how computers can receive instructions. And way back in 1936, Alan Turing thought of this concept of a Turing machine, and he proved mathematically that it could compute anything computable. And that's still the standard today. So real programming language can be used to solve any computation problem. All right, here we have, in the far upper left, a transistor. You can maybe still buy this at Radio Shack. It's a basic electronic, basic electronic component, and here's the diagram that describes the transistor. And we can think of it as a switch that is controlled by electricity instead of like an on and off switch. So if there's electricity here at B, that means that the switch is on. And that means that electricity that is flowing from C to E can pass through. So that's your input, your switch, and your output. Now if we take two transistors and hook them together with a couple of resistors, these little guys, then we get what is called a logic gate. This particular one is an AND gate. There's also ORs and NOTs. It has to do with Boolean logic. So this AND operation takes two inputs and returns one output. Let's just assume that there's electricity flowing through. We've got it hooked to a battery or something. And this here is a truth table. This describes what the circuit is doing. If both inputs are true, then these gates are open and the electricity flows out to the end, and that signal's true. So we can think of it as true, false, 1, 0, on and off. So that's how the computer thinks, basically. And if you take a bunch of those transistors, combine them into these little integrated circuits, again, maybe you can get these at Radio Shack, you can build this little circuit here, and this will actually add binary numbers together. So if you want to, you can get a switch and some LEDs and go make this. So that might be fun. So we've just seen how we can take 35 transistors and add two small numbers together in binary. And this is approximately the computation ability of a newborn baby chicken. I looked it up. But what we've got at our fingertips is 1.4 billion of these guys. So we can browse the internet and look for pictures of chickens and run Outlook and PowerPoint and iTunes all at the same time. And it's pretty amazing if you think about it. But how do we program these things? So here we have an example. This is, oops, there it is. This is the language C, actually. This is a hello world statement. I'll be talking about that again later. For humans, we need an input device and an output device. But the computer still speaks in ones and zeros. So this is called machine code. And in between our programming language and the machine code, there's going to be some steps. This is an example of assembly language, kind of, probably not real, but it's a lower level language, and you might run into this like if you needed to write device drivers, or if you needed to optimize your code to be super fast, like for gaming maybe. You would be writing this old school assembly language, and then that would get run through a program called an assembler and turned into this machine code, which the computer can execute directly. So, but above that level, we have, another thing about assembly and machine language I should mention is it's dependent on the hardware. So these instructions, that you might give to, a Pentium processor might be different that, the instructions you would give to another processor. So it would be awkward, if programmers had to learn a new language every time a new processor is designed. Honestly, there probably is a new language more than as often as there is a new processor. But anyway, what we want is a language that will work on any machine. And most modern languages will do that. So there's two different types that we're going to be looking at, basically. There's compiled languages and interpreted languages. And compiled languages, we talked about assembly needing to run through this little program called an assembler before it became machine code. A compiled language needs to run through a little program called a compiler before it can become executable code that your computer can actually run. So it's like an extra step. But an interpreted language is run you write your code and then you tell this program called an interpreter, go run that for me. And the interpreter takes care of talking to the machine, basically. So in this scenario, we take like one extra step before we can run our code. In this scenario, it may take a little bit longer to run your program, but you may or may not even notice. Java, a little different. We'll talk about Java in just a moment.
So, we just saw 7 different programming languages. And that is a fraction of the thousands that have been developed, are still in use, have dropped by the wayside. When I first started, I'm like, why isn't there one unifying language to rule them all? Which is a good question. So, how many people here speak Esperanto? It's this, I think from the chuckles, people kind of know what it is. It's this kind of created language, supposed to be politically neutral, easy to learn. It's actually spoken by upwards of 2 million people around the world, but it's not nearly as prevalent as a universal language should be. So, like Leslie said, there's assembly and machine and like very basic code, but it's really hard for humans to kind of interact at that level for any extended period of time. So you start adding verbosity, more English or native language functionality to code, but you're getting yourself degrees of separation from the most basic level. So you have, assembly, you have basic, your C, and then like, okay, everybody's working with that now. But you have somebody off on the West Coast, and you have someone on the East Coast, and they're working on 2 different projects, and someone with a big ego says, I can do this a little better. I'm going to modify this language so it can do this, that, and the other thing that much better. And other party says, I can do that much better, and I can do this and that thing. So suddenly, one language has branched off into 2, and that just keeps happening. So languages evolve based on location. Actually, there's a really interesting little talk about one of the first Arabic programming languages. In one dialect, 1 and 0 is true and false, but in another dialect, 1 and 0 is correct and incorrect. So languages develop on their just geographic location based on the function it needs to do. As devices and new functions on, say, the internet prop up, and people go like, I really need to do this, and they kind of shoehorn a language into doing that process, and they tweak it and modify it by degrees. So it keeps changing and changing and changing until that language just becomes something completely new. Languages also have different scopes of functions. Some languages can do a very small degree of things, and before they even get to the edge of their capacity, they're just like, nope, I'm done. Whereas some languages, like C, I guess, will just do everything you tell your computer to do, from doing the most basic things to frying your processor, erasing your hard drive, making your motherboard melt, all those good things. So it's like, okay, I'm going to do that, dead. And
all right, so let's start with C, as Jason just mentioned. It's still considered a low-level language, but it's a whole lot easier to use than assembly. It's useful for writing operating systems, and it's even used to write other programming languages. Created by Dennis Ritchie in 1972, and still used today. And we've got C++, which is an object-oriented version of C, and I promise I will talk about that later. C# is Microsoft's version of C. Objective-C is Apple's version of C. They also used it to write operating systems. And most of the programming languages that exist today borrow heavily from C, even if they're not directly called C. Also, Dennis Ritchie died the same year as Steve Jobs in 2011, so we should remember him too, because he was pretty important. Java, created by a group of engineers. Oh, well, watch out. You have to. All right. Oops, sorry. Okay. Created by a group of engineers at Sun Microsystems. Another object-oriented language, cross-platform. So Java was designed to be write once, run anywhere, or as the developers say, write once, debug everywhere. It was originally, one of the first things programmed in Java was an interactive handheld home entertainment controller that was originally targeted at the digital cable television industry, but the cable industry did not want it. But later in 1995, Netscape thought, well, we just need to, put this in our browsers. This is great. We can run programs right in our browsers. And so, who remembers applets? Yeah, they were really, really slow. It's probably not the best idea. But, this write once, run anywhere philosophy enabled it to run on all kinds of, devices like the Android. So Android apps are now written in Java. And when it's running on a server, it's like, it scales really well and it works really well. And so Google, eBay, LinkedIn, Amazon, all mostly written in Java. But it does have this issue with security in our browsers, and so the latest Chrome browsers are actually disabling it. And even on our desktops, it's kind of annoying. So JavaScript, not really related to Java at all, except that Netscape, I guess, liked the word and thought it was good for marketing. It was written in just a terrible hurry. I saw 10 days or 2 or 3 weeks. Anyhow, it is a client-side language, which means it's designed to run in your browser, so it's much faster than Java. And then there are libraries like jQuery that make it even more useful. And let's see, it can manipulate any element of a web page in real time. And we'll be taking a closer look at JavaScript a little bit later. So this, here we have Rasmus Lerdorf, who has famously said, I don't like programming. He also said ugly problems often require ugly solutions. So this programming for the web problem has been around for a while. PHP, I believe that also came out in 1995. It originally stood for personal homepage, and the idea was that you could use it to get a site up and running very quickly. The problem with it is that you can use it to get a site up and running very quickly. So there's a lot of really sloppy code out there, and it's also just not the most elegantly designed language. It's just designed to get the job done. But 81.9% of all websites out there on the internet are using some form of PHP. So it's pretty popular, pretty useful. You can write PHP code in the middle of your HTML or vice versa, or whatever. Now for something completely different. Not really, it's very similar, but Python, another language derived from C, basically. Released in 1991, so a little bit younger than the other language. Older than the other languages we've been talking about. The designer of Python, Guido van Rossum, he did name it after Monty Python, so he kind of has a sense of humor about things. He thought that, yes, it does matter if this language is beautiful and readable, and so that's what he was striving for. Because it's so sparse and clean, it actually uses indentation, where some other languages use punctuation to mark out. Well, we'll talk about the elements of a programming language later, but anyhow, white space matters in Python, and it's used again by a bunch of large websites, Instagram, Pinterest, YouTube. So I think even NASA runs a lot of Python. So that's pretty cool. Ruby, again, we're getting further and further away from the machine and more we're talking about languages that are designed for the programmer, not for the machine. And Ruby was actually written it was designed for programmer productivity and fun. You gotta love that. Twitter is written in Ruby. So again, very powerful, functional, like all these languages. Ruby really took off when something called Ruby on Rails was released. It's a web application framework, which is basically a program that makes writing other programs a lot easier and faster. If you want to learn Ruby, there's this just adorable book called Wise Poignant Guide to Ruby. You can Google that. It's written by this character who goes by the name Y, the Lucky Stiff. It's kind of a, anyhow, it has cartoon foxes in it, and it's just really cute, so I recommend it. Basic.
So Visual Basic is Microsoft's take on BASIC, just like C# is Microsoft's take on C. Microsoft has a bunch of their flavors of programming languages it kind of lets someone who's familiar with that language kind of jump into the development of Microsoft applications. Visual Basic and Visual Basic.net, the most recent version, not really that popular or important, but I use this as a segue to talk about frameworks, libraries, and software development kits. Leslie mentioned a little bit ago jQuery as a library or a framework. Frameworks should really not be necessary. It's just a collection of resources for a very specific task that a programmer wants to have at his or her access without having to write them. So I want to make a website and I want to get it up and running. I'm going to use a web framework. I want to make this Windows application. I'm going to use a Windows framework. Someone, when we gave this little practice presentation, mentioned someone like Leslie, who is very industrious and does a lot of things by hand to make sure it's all there, could be said to be a carpenter and is crafting all of this code by hand. It's done very well. Someone like me who would use a framework is someone I would just go to IKEA and buy something and it's already there and I can just kind of prop it up and get it ready to go. That's where frameworks, and they just narrow little kind of slices of projects. Software development kits are big corporate endorsements for a language. And they are actually collections of things called APIs, application programming interfaces. They're all very technical terms to get into this, so I'm going to speak in analogies right now. APIs are like little black boxes that interface between the programmer and the application. So imagine you're writing an app for the iWatch, one of the fancy little wearable devices Apple's putting out now. And we all know that part of the functionality of the iWatch is it can monitor your heart rate. Now, I want to make an app that uses that functionality. Apple has decided they don't want people using that function willy-nilly. They don't want you monitoring someone's heart rate for no good reason or checking their biometrics while they're doing whatever. So there's this API you have to use to get to that functionality. So you say, hey, heart rate monitor API, I want to know this thing. So the API will check like, hey, is this something I can tell you about? If so, here's some information back from the application. Otherwise, no, you don't get to know that. So big collection of APIs, big collection of way of interfacing with applications on a very specific level. So what are you interacting with?
So we've been talking about all these programming languages, and there are many more languages that are less popular, but they all pretty much have the same basic elements, and we're going to talk about those now. The first concept is a variable. You can think of a variable as like a bucket that gets carried along as your program runs, and we put a label on the bucket so that we know which bucket it is. But the contents can vary as the program runs. So this total cost, contains some amount of money, and maybe we're adding to it as the program runs. In PHP, your variable name needs to start with a $sign. So you'll see that sometimes. Maybe num_bolts keeps track of how many bolts are in stock or whatever. And in C, you need to declare your variable, which means you need to say what it is, what kind it is. Int here stands for integer. You will notice a lot of abbreviations in code. So if you see something that's, hey, that looks kind of like an abbreviation for something, it probably is. And variables can contain different types of data, of course. We need variables to hold numbers with decimals so that we can talk about money. We need variables to hold characters so that we can run programs that have to do with words and sentences. Those are called strings. And there's also a type of data, a type of variable called a Boolean. We talked briefly about Boolean logic earlier. This is just one bit, can hold a 0 or a 1. And again, that gets back to that idea of true or false. 0, of course, being false, 1 being true. And a related concept to a variable is a constant, which is like a variable but doesn't vary. So imagine, if instead of a bucket, if you just had this can of okra that you were carrying around, the amount of okra in it is not going to change throughout the program. So another concept, it's a little confusing, but statements and expressions. A statement in a programming language is sort of like a sentence in English. It's a complete instruction that the computer can execute, and it usually ends with a semicolon. These are assignment statements. So like here's one in C, here's one in JavaScript, here's one in PHP. And then an expression is anything that the computer can evaluate and come up with true or false. So like, is A greater than B? Or we could just write true in PHP, and that would evaluate to true. And so here's a statement where we have an expression, and then this variable, total cost, is equal to whatever this expression evaluates to this way. But we probably need to deal with data that's more complex than just one variable. And the most common kind of data structure that you'll see is an array. It's pretty easy. You can think of an array exactly like a list that is in a particular order. And because computers are the way they are, we will start numbering at 0. So the first element in an array is element number 0. So for some reason, we're setting the first day of the week to Steve. So that's what's happening there. And in addition to having numbered array, these are called indexes. We also have some kinds of arrays, like in PHP, you can use words instead of numbers. So you can create, this is also called a hash. It can be thought of as a set of pairs. These words that are used as indexes are called keys, and these are called values. You may have run into this concept if you've done a good bit of HTML and CSS and that kind of thing. So the keys must be unique. Like if we say, the color of yams is equal to orange, and then, later on we say the color of yams is equal to purple, we've lost the original value of orange. So I hope that kind of makes sense. The next concept that we need is a function. You can think of a function as like a little machine. Sometimes it just runs and doesn't need any input. Sometimes it needs input and returns output. after it performs its task. Basically, with every programming language, you're going to get a lot of built-in functions for doing very simple things like displaying text on the screen or opening a file. Functions are also called subroutines or procedures. And notice the parentheses. If you see parentheses together like that, that's a good indication that you're looking at a function. And you can write your own functions, of course. So the idea here is that if you've got a basic action that you're going to need to do more than once, like opening a can of cat food, you might as well write a function, and then you can just call it the next time you need to perform that action. That's what it's called when you run a function, you call it. So we can't put it off any longer. We have to talk about object-oriented programming. Okay, so this idea goes way back to the early 60s when some programmers in Norway were looking for a good way to simulate real-world situations, like they wanted to optimize waiting for an elevator or traffic lights or something like that. I'm not really sure what they were doing, but something along those lines. And so they needed to break down real-world situations into basic concepts of of objects and the actions that those objects can perform. So in this case, maybe our objects are the elevators and the people, and the actions are like pressing a button or moving to a different floor. So the objects can also have properties, and the property might be, what floor are you on right now? And so let's say we want to write a program that has something to do with cats. We have this abstract notion of a cat. This is like a template, and we could say that anything that that belongs to the class cat is going to, well, actually I said that wrong. Anything that is a cat belongs to this class or category called cat. Okay. So these cat objects are instances of this class. And the cats have certain functions that they can perform, and those are called methods. And there may be data associated with each cat, like the name or their mood, maybe. And those bits of data are called properties or attributes. So that's just a lot of words. Let's look at a little example in JavaScript. Here we're creating a new cat. So we're saying this is a variable. It's an object. Its name is a cat, and it's an instance of the class cat. So cat, we assume, is a class that exists that somebody else defined. We're assigning this cat has a mood in this class. Things like mood, age, and meow, we're assuming that's defined in another file. Sorry. The mood we're going to say is happy. The age for this cat is 4, and when we say a cat.meow, we want the cat to perform that procedure and meow. So hopefully that makes a little bit of sense. The next thing we'll need to look at, it's basic to all programming languages, is controlling the flow of the program. So imagine you're looking at a page full of code, and you're the computer, and you start at the top, and you start executing these instructions one by one. But sometimes the instructions say, okay, we need to perform some kind of test. And based on the result of that test, whether it's true or false, we're going to do one action or another. So maybe you've seen flow charts like this before. Maybe they've been just as silly as this one. But basically, it's a really good way of organizing things if you are going to write a program, because if you end up jumping around all over the place in your program, you can end up with what they call spaghetti code. It should actually, this is like a pretty good, well, this repeats forever, but aside from that, this is a pretty good logical flow. So the kind of things that will control the flow of a program are, if-else statements and different kinds of loops. Those are the most common ones that you'll see. So we can imagine, thinking about the cat that we just saw. If things is greater than 0, knock over things, else nap. So it's, it makes sense. It's almost like English. And the if statement just says that, look at this expression in the parentheses, evaluate it. If it's true, do what's in the curly brackets. If not, you can either stop or you can have an else and then, ask the program to do something else. There's a couple different ways to loop. The while loop keeps going as long as this this expression evaluates to true. So while things is greater than 0, knock over things. Now we're going to hope that whatever's going on in the curly brackets changes the value of things, because if it doesn't and things is always greater than 0, then we're going to loop forever. So if you ever have a program that's looping forever, you might want to check for that. See if there's a while statement that's just never changing the variable that's supposed to. And then this is a for loop. It's really not super intuitive, but we've got 3 things in the parentheses. The first thing gets executed first. In this case, it's assigning the number 0 to this little variable I. And then the next thing is a test. We're going to see if I is less than 5. If that evaluates as true, we're going to perform the action that's in the parentheses. in the curly brackets. And then after that happens, we're going to increment that variable by 1. And then we're going to perform the test again. So it really doesn't make sense. You just kind of get used to it, I'll be honest. But that's a for loop.
Okay, so we're all ready to write the next $1 million app, right? We're good to go. We've just laid a lot of knowledge on you, and it's a lot to try to keep in order, but just kind of read through this while I'm talking, and I'll tell you a story. When I first started going through the process of programming, I was doing this in the early aughts, where the height of humor and being clever was to assign stupid random things in the middle of otherwise normal situations. So I would write code for my programming assignments, and I would have integer fork and function opossum, and this got me, I had write up the assignments, and I would do just fine. And then as things got more complicated and I was writing all this stupid code, I would turn to my friends and say, why isn't it working? And they would say, you idiot, clean this up, label everything properly, we can't help you like this. And that happens for just about every programmer. They all want to write their code so it's readable and understandable for them and everyone else on their team. So as you're looking through code, if you ever find yourself having to stare at code, you can learn a lot just by the way it's laid out, the way things are named. Look at the way this gets indented and spaced. Aside from Python, which Leslie mentioned before, which is beautiful and uses the white space and indenting and spacing and putting stuff on new lines is all a construct for us to understand it as humans.
Just so you can read it.
It's all so we can read it. So even if you don't know everything that's going on, you kind of take a step back, fuzz your eyes. You can kind of get an idea for what is working. Leslie worked through a lot of the elements that are going on here. We have this integer count. Something is happening with count. Count is being compared to the number 500 for some reason. Count is being plus plus. I don't know if it's got a Google Plus count or whatever. This printf thing is happening. And when you're looking at code, there might actually be some chunk of English, something readable, something that will give context to the code. That will help you put in, aha, I couldn't figure out the 6 line before and the 50 lines after it, but here's one thing that gives me, okay, this is throwing an error, this is notifying me of something. And then, so even if you don't know what a lot of these terms are, 90% of it is gone, but 10% of it is there, and that's a lot of the times all you really need to evaluate. But sometimes that's not enough. Sometimes you need a little bit more. And that's where some of these resources come into play. A lot of programmers will go off and do their thing, and then they'll write up their code, and they'll run it, and it breaks. And like, okay, that makes sense. I have no idea why. I'm going to Google that error code. I'm going to go to one of these databases and look up the functions. What is it? What kind of inputs is it expecting? What does it want me to do with an output? So here we've listed some of the resources that you can go to. You've exercised your limits of understanding. You're still being flummoxed. These are the kinds of things you want to go to. Otherwise, some of these are also, I've got this chunk, or I've got this piece that I want to experiment. I'm going to plop it into this nice little sandbox, and I want to run it and play with it. Tweak a variable, tweak a function, see what it shoots out, see what errors it gives me. Personally speaking, I like to take a piece of code, run it, break it, try different things with it, just so I can build my own understanding. I know Leslie has a couple of different methods for kind of understanding or working through code.
Well, I wasn't prepared to talk about that, but I will say, if you get a chance, go to tryruby.org. It lets you step through a cute little tutorial with the cartoon foxes that I mentioned earlier. So, and let's see, these are good, just general, learning websites. Let's see, Bento it's sort of like, it's like a big listing of other websites. So like how to learn every language you could possibly think of. Yeah, that's about all I'm going to say on that one.
So, we've talked at you for about 40-ish minutes, and we're all here for some reason or another. The Onion is something Wise Guide to Ruby talks about. It's, you open up, suppose you've got this book that's going to tell you all about programming languages, and you open up and out pops an onion. So, it's like, why the onion? It's a very Dadaist approach to programming, but don't worry about the onion for now. Let's just look at what does code mean now? There's been a lot of people talking about, and it's been kind of the undercurrent that coding might actually be the next level of basic competency or literacy that we're going to need to be comfortable with moving forward. Just like in the very earliest steps, being able to read and write was the most important thing during your job. Being able to use a phone or a typewriter. Being able to use a computer. Being able to use the internet. Just 10 years ago, 15 years ago, did you need the internet to do your job? 20, 25 years ago, did you need a computer to do your job? In the next couple of years, there are people who are kind of looking out like, will you need to know code to do your job? We're seeing that this Internet of Things where everything from your shoes to your hat to your car to everything is going to have some level of communication, some computer in it talking to something else. And being able to kind of take part in that conversation is going to be increasingly important for us. In the session yesterday about LII and teaching students tech literacy, I think he made a point that really resonated with me. It's that teaching students, teaching ourselves, especially in the legal sphere, all learning about code is going to get us doing is working on patents and copyright problems. So, but learning about code actually enables us to just have conversations with coders, with programmers. It enables cooperation. I forget the term right now. Learning about coding is also a great way to advance your problem-solving skills. It's a way to breaking down situations into discrete chunks, understanding the flow, understanding how the input translates to the output, what might modify the flow. And if the futurologists are anything to go by, we are all going to be replaced by computers soon, in the next couple of years. So why don't we all learn coding so we can write the programs that will replace ourselves, so we will at least have some job security. All right, so we'll leave this up to you. We can open this up to a Q&A session, or we can jump right into our coding example.
Does anybody have any burning questions?
I have a question.
Sure.
If you are a complete newbie to coding, what would be the language that you would recommend you start with?
Boy, it depends on what you want to do. Like, do you want to build websites or write apps, or, you know, do you have like a big server that you need?
If you want to learn, I think Ruby is actually a really nice place to start. I tried Ruby websites.
Yeah, I would probably do that, actually. Oh, yes, in the back.
To kind of piggyback off of that, though, how quickly do you think for someone who's a newbie, how quickly would you introduce them to something that's not duck-typed? You know what I mean? Because I think starting and spending too much time with a duck-typed language, there's a little too much magic happening behind the curtains.
You might want to explain what duck-type.
Yeah, there's, would you?
Yeah, so if it looks like a duck, quacks like a duck, it's a duck. So in something like Ruby or Python, it will magically infer what you mean that variable to be. Whereas if you're working with something that's strict, like C, C++, Java, you need to say it's an integer or it's a string. And if you want to use it in a different way, you can cast it, or, you know, if you're lucky,
You have to jump through several magic functions.
That's several levels.
Yeah. So in short, how quickly do you think someone should be exposed to that?
I don't know. I mean, I started programming. I mean, I learned, you know, C a long, long time ago, but I started programming in Perl. And honestly, I still think that's like just a delightful language that you can like get in trouble really, really quickly with. So I'd almost recommend that, but nobody seems to use it anymore. So I don't know.
I would advocate for Java, actually, just because.
Thank you.
Okay.
Thank you.
I mean, in Java, it's the language that gets used the most. It'll get you comfortable with using being object-oriented programming very fast. It has a lot of the languages we just covered. It's got most of those basic elements covered very securely. Just you can go out onto Google and out onto the internet and find a world of resources about Java. So that would be. I mean, if you wanted to take someone's hand, Ruby, something like that. If you wanted to actually be I want to say I can do this, I would recommend Java.
Yeah, depends on what you want to do with it. So.
Just to support an earlier point of yours, I'd like to point out that all the people who were making noise about 30 seconds ago in the back row work for the same organization.
Oh, okay.
And we're on the verge of religious warfare. So.
Oh my goodness.
Okay, so who's in what camp then?
He's Java.
Okay.
Perl.
Oh, hey, well, there, we understand.
What about Lisp?
Oh, you know what? All I really know about that is it has a bunch of parentheses, right? It's supposed to be very elegant. So yeah, learn that.
Lots of superfluous parentheses.
Yeah, so that sounds right.
Legislature. You know, in response to what Tom said, yeah, Java will be the base for a lot of stuff that you'll encounter, but it is very robust and repetitive. So you'll be saying a lot of the same things over and over again, but it'll give you a better understanding of what those duck typing languages are doing behind the scenes. So when you get into those situations where you're like, what just happened, you might be able to more easily debug what actually occurred because your variables got messed up. And you know, your list of resources, you forgot to mention Stack Overflow, which is immensely helpful with everything.
Yeah.
And any programming language is going to have its own language API site. So you can go there and find a list of all the core functions that any of the languages are using.
So this coding exercise is going to be extremely basic. So everybody in the back, just go to tryruby.org and mess with that while we're doing this, because this will be pretty useless for you. But those of you who have never touched code before, is there anybody here who's just like never written any code before? Okay, well, we have a couple, looks like. Awesome. If you have your computer with you, if you have a text editor such as Notepad, if you have a web browser, go ahead and get those things assembled right now. Oops. Notepad. There we go. Come on, Notepad. Yeah, I'm serious. This is very basic. So this is what we referred to earlier as the Hello World program. Doesn't look like anybody's really following along, which is just fine. So you may want to open up your text editor and type this bare bones HTML document, and then put a script tag in the middle of it. And what we're going to do is use this cheap and easy built-in function called alert so that we can say hello world.
In the first line, is that?
That is,
Oh, is there a way to make that? Let's see.
let me see.
Hold on. Oops, view. No.
Format.
Format, thank you.
Fine.
There we go. Come on.
That'll be
Yeah,
nice.
yeah, I like that plan. All right, let's see if we can. Oh, that's a little big. All right, sorry, you guys. Okay. So has everyone gotten their HTML all written? Okay, thanks. All right. Now the trick is we need to save this as an HTML document and not html.txt. So let's, I've already done that actually, so I'm just going to say file save. And then we want to open it in a web browser. Oops, come on. Come on. Where are we? Ugh. Did I actually? I may have done what I said. Yay! Okay, so the box popped up. It said "Hello World." That's really all there is to this example. So, did anybody have any trouble along the way getting their text file saved as an HTML document, or?
Can you go back to the text file?
Pardon?
Can you go back to the text file?
Sure, sure.
So
Yeah.
what language is that?
So this is JavaScript. I should have mentioned that. Chosen not because it's the best language, because I don't think it is. Not because it's the easiest to learn, because I don't think it is. But you can open up, Notepad and just start, which is kind of cool. And there are some resources on the web that'll help you along. With JavaScript, I think it's been called the language that you don't have to learn in order to use, which is not really true. You probably should learn it before you use it, but mostly people don't. They just Google for like, hey, I want a JavaScript function to do whatever, And we had a situation just recently where our librarians like to make a big deal about the graduation and the countdown, how many days till graduation. And so it was requested that we put on our website, a little like countdown to graduation. So Jason spoke earlier about like my fine artistry and hand coding, but I just went and Googled, okay, JavaScript countdown. I'm serious because that's easy. So I'm sorry.
Also because I wanted it yesterday.
Oh yes, and Maureen was like, she wanted it right away. So here's what we ended up with, and I'm just going to jump into it and we'll just take a look at it. And this could use some optimization. It's pretty ugly, but this is exactly what we stuck into our a block in our Drupal site. And I changed the date to be graduation next year, so we can start counting down. So whenever Maureen wants it, we can put it up. But you'll see. Let me grab that. Is this the thing? Yeah. So it's going to be. I mean, you can go out on the web and Google for a JavaScript function. Quality is going to vary, but if you need to get something done quickly, it's actually a great way to go. So we've got all these variables, and we're doing all these calculations. There's something fancy going on here with the set interval function, and we talked briefly about functions earlier, but we didn't talk about how to define them. So here we're defining a function with the keyword function. And this function is called show remaining. And then at the bottom, we're going to say, we're setting an interval, and we're going to say, run this show remaining function, and then wait, 1,000 milliseconds, or whatever. So anyway, it's going to run this and update for us. So let me show what it looks like.
Can you just open it up in HTML?
Yeah. And again, this, it's actually kind of an ugly example because it's got a lot of redundancy, but it does the job, and there's your countdown. So I don't know. I wanted to come up with something that we had actually used in JavaScript, and this is what I came up with. So anybody have any questions?
Okay, I'm sorry.
Yeah, no, that's fine.
When you, like the original Hello World, where did you put it on the web? Like which site did you put it at?
It's not actually. You can run it off of your laptop.
Oh.
So that's why it's a good sandbox to just play in. So also alert boxes are terrible and you should never use them. So.
Yeah.
You spoke about GitHub earlier.
Yes.
Could you go back to that and talk about it a little bit more?
GitHub?
GitHub.
We don't use it. I mean, I've used it for like a app that I was developing that didn't have anything to do with my job. So that's about it.
I mean,
would you guys in the back like to talk about GitHub?
We use GitLab internally. So
a role in GitHub.
yeah. So Git is Git. Git's a version control system. GitHub has evangelized it, and it's a nice free way for you to source control your stuff. I will say, remember that the free version is public, and there's lots of credential scrapers out there that will grab sensitive stuff that you accidentally commit to a public repository. But beyond that, the overall idea is if you had a document, and as you were going along and adding things to that document, if you could suddenly go back to a tagged version of that document instantaneously and start working with that, or branch off of that and do work there, that's the overall idea of version control system. So GitHub is just a central repository for that, and you can collaborate with other people if you want them to.
But it also has a function as a deployment tool, Nick. I mean,
Yeah. Well, that's
talking about that.
yeah. That's a whole other thing. So in its minimal form now, we're using it as a deployment tool where we'll have particular branches that are protected as a production branch.
Sure.
And that code has been tested and kept pristine so that our development code isn't polluting that production code that we know works well in that branch. But that's kind of going off a whole other tangent. So
there's a big whole, like, theoretical conversation between two developers just discovering GitHub. Like, did you know you can start working on code and then save it in a centralized spot and start developing more and more, and if you break it, you can go back to the other version, but if it's really cool, you can share it with the world, and everyone else can make it really awesome, and one of the developers faints because it's the best thing ever. It's the kind of things programmers get really excited about. And that's cool too.
Dangerously so.
Yeah. Well, thank you very much, everyone.
Thanks
We'll be
for
around.
coming.